So today, we need to talk about oblique asymptotes, otherwise known as slant asymptotes. If you take the equation that I've given you here, so if our function is equal to x squared minus 3x minus 7 over x plus 3, if you put this equation on a graph, you would end up with this picture. Now, notice from this picture, there's a vertical asymptote, looks like it runs here, ish. Right? Okay, but the horizontal, there's no horizontal asymptote. That doesn't make sense. So what you have when you don't have a horizontal asymptote in this situation is you end up with what's called a slant asymptote, or an asymptote that slants and goes diagonal across your graph, right? Now, that's a very rough sketch. But what we have in this graph is we can tell there's a vertical asymptote and we can tell there's a slant asymptote. So if we come back to the equation, in order to find the vertical asymptote, we have to factor our situation and make sure there's no holes first. So two numbers that multiply to -7 and add to -3, there are none, so there's no holes. So our vertical asymptote is just x plus 3 equals 0. So x equals -3. So we should have a vertical asymptote at x equals -3, which is about where I drew it, okay? Now, we said there's no horizontal asymptote, which should be true if I look at the equation. So remember, the horizontal asymptote, we look at the exponents. There's an exponent of 2 in the numerator, but the denominator has an exponent of 1. So this is going to follow the rule where we have bigger on top means that there's none. So just like we thought, there is no horizontal asymptote. When that happens, there is a slant asymptote situation. We haven't talked about how to find the slant or the oblique asymptote, but it's not hard. In order to find the slant or the oblique asymptote, you have to use long division. Okay, so we got to remember long division. We're going to put the numerator inside. So x squared minus 3x minus 7. Put the denominator outside. And then you have to ask yourself the question, what times x is going to give me an x squared? Well, I know x times x would be x squared, so you put the x on the top and now multiply. X times x is x squared. X times 3 is 3x. Then we have to subtract all of that. So x squared minus x squared is nothing. -3x minus a positive 3x is really negative minus, right? So a -6x, bring down the -7. Okay, now ask yourself, what times x is going to give me -6x? Well, I know that -6 times x is -6x, and -6 times 3 is -18. Okay, now we subtract those. So -6 minus the -6 is nothing. -7 minus the -18 really means you're adding 18. So we end up with 11. So we have x minus 6. Our remainder is 11 over x plus 3. So we would say, remember, we don't write that. We write it's plus all that. But the slant or the oblique asymptote, all you care about is this. So ignore the remainder, and we have a slant asymptote at x minus 6. Now, on the graph, remember that this is an equation of a line, right? If y equals x minus 6, this linear equation, you have to remember that you really have one x minus 6. The 1 is your slope, and the -6 is your y-intercept. So I should have an asymptote that hits the y-axis at -6 and then has a slope of +1. So I've graphed it on here. So we go, this is at -6, 2, 4, gets down by 2. And then it goes up and over, up and over, up and over, right? So it's same Up 1 over 1, up 1 over 1, up 1 over 1. And that's the slant asymptote that we have. So just to recap, when you don't have a horizontal asymptote, you need to look for a slant asymptote. A slant asymptote is going to follow just a linear equation, and you find it by dividing.